Okay, first and foremost, so we are live, we are recording.
Oh, yeah.
So,
Hello.
quiet please. We are going to be starting on weathering and erosion. So unit 2, chapter 1, lesson 1. So 2.1.1 is the lesson we are on. 211. So get that in your notes at the top. Lesson 211. We're on page 64 is where we're starting. And as you've probably seen, page 64 to page 90, that's a lot of pages right there. So this right here, there is a lot of lessons in here. If you kind of just flip through the different lessons, I think there's like, it goes to 217, I think it is. Correct me if I'm wrong.
How many units were there?
5 or 6.
Wait, what were like way after this?
There's 214. We go to 216. It goes to 216. So everything in this is talking about erosion and the different types of erosion. So this is pretty much what we're just gonna be starting this today and tomorrow. And then pretty much the entire month of January, this is what we're gonna be talking about right here. Weathering and erosion. Yes, Dylan?
Why in the lesson doesn't say mechanical?
What?
Why is the 211 in mechanical weathering? That's what it is.
Because that's what I'm about to talk about right now. So in your planner, this is very important for you guys, my people here in person. Those of you here in person, you got to turn in finished science fair research hypothesis, question, purpose, all of that worksheet with the research that is due for you guys Friday.
Oh, yeah.
That is due for you guys on Friday. Those of you online, you guys can turn it in when you come back from Christmas break. So on December 3rd is when that'll be due for you guys. If you want to, you can turn it in sooner. Notes, working on 211, Dylan, that's what you were talking about. We're starting with mechanical weathering. Then we're gonna get into chemical weathering and yada, yada, yada. There's a bunch of different types of weathering and erosion. So mechanical weathering. Before you guys even start reading the lesson, because I didn't tell you I wanted you to start reading the lesson or get the vocab words written down yet. Before you start reading it, I want to ask you, when you think of mechanical weathering or erosion in general, what do you think of when you think of the word erosion? Most of you should know what erosion is. I would say 9 out of 10 of you students should know what that is. Ian?
I think of like this rock that's being chipped away, like when my dad. What? Yeah.
I like that. So thinking of a rock and it over time getting chipped away. Yep, that's a type of erosion. Johnny?
I think of chemical weathering, like, but with water.
Yeah.
Like, when you step in rocks all the time, like sediment.
Yep. So water just hitting any type of rock, and there's going to be sediments that come off of that rock. Max? Yeah, I like the expanding piece that you talked about.
Yeah.
I'm going to show you guys a picture here real quick before I move on too far. Frozen water bottle.
Oh yeah.
Oh, yeah.
How did it?
That area is exactly.
So that's not the exact thing I was talking about. This is what I was talking about. Let's look at this. Open image and new tab.
Remember, like a slow can or so in the freezer?
So that's what I'm about to ask you guys about. This right here, you can all see that this is a frozen water bottle, right? So with these frozen water bottles, what is happening when you freeze the water? What happens when you freeze the water in that water bottle, Caleb?
It's expanding, crystallizing. Right, also they go on, but that's also they're separating. They're also bonding, but when they separate, it creates pressure.
Yeah. So why is it when you freeze a water bottle, the water bottle is expanding? The molecules move apart. They don't move apart.
No,
Aries?
it's because when water turns to ice, ice is actually less dense than
There
water,
it is.
so it expands.
Yep, so that it's all about the density. Anything that is in solid form, well, not anything in solid form, but if you're going from liquid to solid form, it's about the density. The density of solid water is going to be less dense than your liquid form. Next part I want to talk about. So one thing I want to talk about is roads. Why do we have to repave roads over time? So a lot of roads, like especially the one out in front of my house, the road it's got some divots in it and it's got just a bunch of chips in it. Ever since I've seen my road, it has been just worn down. It wasn't like that when it was first put in, but why is it that we have to repave roads over time? Why do we have to repave roads over time? Ian?
Weathering.
Weathering? Yep, that is why, but
Eroding, and all of that traction on the road, all of the pressure, all of the rain.
okay, so like cars and tires driving on it,
Yeah, so the.
but
physical part.
not just that, it's kind of a little bit more than that. Max?
The one thing that could happen is like plants and stuff together, split it.
Yeah,
And then like ice and then like.
yeah, you could have plants growing underneath that. It's going to cause some type of, like if there's a tree root,
Yeah.
underneath, that tree root could keep growing and break up underneath. Dylan?
So drive onto too much of it, potholes and it can develop water and stuff on it, and then make cracks. And you got like,
There could be ginormous cracks, but what's causing the road to erode is what, Aries?
Well, a few things. One is just like like he said, just stuff getting cracks and expanding like water.
Yep.
And also just the pressure put onto it slowly breaks it apart. Like where I live, like people in big trucks aren't supposed to go up there, like logging trucks and that. They are prohibited by the city to go up there because the roads aren't built for that.
Yeah,
They go
too much
up
weight.
because last winter a bunch of them ignored it and they broke the roads completely.
Yeah.
And then when it froze over, it just basically took out our whole road.
Right.
We can't have the road anymore.
Right. So with most roads, Johnny, I'll end on you here. Why do you think?
well, all that stuff in, like when we talk about sidewalks, the cracks will get bigger.
The cracks will get bigger? Roads?
It's like, well, it's basically a big sidewalk.
Right. So let's look at some of these pictures here, some of the erosion happening to some of these roads. So first off, you're able to see with some of these, this one right here, there's just a big, massive sinkhole, right? We don't see that as much around here. That happens a little bit. Right here, we see a landslide, right? Big old landslide. That can happen. But some of the roads, especially on some of those old country roads, you're going to see the roads breaking up like this, right? Not really seeing what I'm wanting here. Wow, there's some crazy ones. So a lot of the time what's happening is it's not, a lot of you are saying in your answer that it's coming from cars. It's coming from pressure from cars, right? It's actually not the cars driving on it that's causing the most amount of wear down to the road. It's actually going to be the amount of rain, the amount of snow, the amount of ice, right? And then over time, the part that you guys are thinking of with the car tires is thinking of when we use de-icer on the roads or when you use chains on roads, the chains are going to break it up a little bit, right? But mostly it's going to be water, it's going to be ice, it's going to be snow that is breaking down for the most part, all of that. And then it's going to break it out from below.
Road there is just going.
Yep. Kind of like hail. Yep, hail's definitely going to do that as well. Okay, so with that said, I think that's a good enough introduction to what we're talking about with this lesson. So go ahead, start reading lesson 211. Got page 64 to 67, so about 3-4-ish pages. Make sure you read the stuff that's in the side sections as well. So read the try this section, look at the pictures and the history part. I definitely want you to look at the history part as well, because those are sections that I can pull questions out of as well. So read those areas. I'm not going to give you a whole 20 minutes because I just don't think you guys need it. 3 vocab words. If there is there any, how many? 2. Biological and physical weathering. So yeah. So get those italicized words written down as well. I'm going to pause the recording. All right. So we just finished writing down our vocab and going through the reading. So those of you who did not finish it, I think all of you did, but those of you who did not, you need to get that done. Those of you who are online, go ahead and pause the video now so you can get the vocab done and then resume the video when you're ready to keep going. I think I'm recording. Yeah, I'm recording. Okay. So first things first, yes, get this slide written down. Yes, get this slide written down. Weathering in general is the breaking down of rocks and other materials on the Earth's surface. Weathering is the breaking down of rocks and other materials on the Earth's surface. So for mechanical weathering, we're going to be going over mechanical and chemical weathering. Chemical weathering will be next week. So with mechanical weathering, who can read me the definition of that one? Aries, go for it.
Breaking down of rocks by physical processes.
Perfect. And then just jumping ahead to what we're going to be talking about with chemical weathering, who can read the definition of chemical weathering for me? Bethy? Yep.
Okay. The breaking down of rocks by chemical processes.
Yep. So what's the difference between the two? One of them is broken down by physical processes. The other one is broken down by chemical processes, right? So those two should be pretty easy for you to remember which one is which. But what's going to be the harder, the actual challenge between the two is determining what is an example of physical weathering and what's an example of chemical weathering, right?
Does physical weathering include like water?
No, we'll talk more about what water would be considered.
Chemical thing if you're the-
Right, so it depends. Water can actually be an example of both in some ways. Okay, you guys good on this one?
I just have one.
Okay, Aries, almost out of waste.
That arch in the bottom is being short. That one looks like it's gonna fall. The rest of the bottom.
I've been to the one in the top right corner. I've been there.
Yeah, that top right corner one is, yeah, I've actually been there too. That one is,
Especially
I went up there and learned
Pretty-
100 miles an hour.
can't remember which state it's in, I think Colorado, maybe.
Really?
Okay. So we have 2 different types. Quiet, please. We have 2 types of weathering, 2 types of weathering. So let's start off with our physical. Our physical, also known as mechanical weathering. So what is happening? So Max, you brought up the great point of what really is the difference between physical and chemical change. So physical change, it's still the same technically. A physical change, it's still the same, right? If I were to do a fun example where Mr. Doomer breaks something.
Yay.
I love
Whoever
it.
just
You want to pop my back?
stop chewing on my pencil. So we have a pencil here, right? We can all see that this is a pencil,
The
correct?
one that has no lead. The one with
All right. So this pencil, we can all agree that it's a pencil, right?
Yeah.
Yeah.
Wiggle it, do the wiggle.
Ooh. Okay, pencil. It's
Oh,
broken
no,
now,
you
right?
broke
Oh no, my
it.
pencil, it's broken.
What do I?
So,
do?
with this pencil, was that an example of a physical or a chemical change? Physical change. Why was that an example of a physical change? Who can tell me why? Johnny? The chemical composition is not different in any way. This is a physical change because all I did was I changed this from one whole pencil and two whole pencils. Well, not two whole pencils, but it's now half a pencil, right? The chemical makeup is still the same. It's still made out of wood. It's still made out of lead, right? Everything about its chemical makeup is still the same. Same goes for physical and chemical weathering. So physical change, there's no change in its chemical composition. There is no change, no change in that chemical composition of the rock. So the rock is still, if it is a sedimentary rock, it's staying a sedimentary rock. If it's an igneous rock, it's staying as an igneous rock. It might be breaking up into two different igneous rocks, but overall, its mechanical makeup, its chemical makeup, I mean, is still the same. So agents of mechanical weathering include expansion and contraction. Expansion and contraction over and over again. A good example of that is our water bottle example, right? What happens when the water bottle freezes? Is it expanding or contracting? Expanding. Our water bottle expands
And when it thaws out,
when it is going to freeze. But when it melts, it is now going to contract. Expand, contract, expand, contract. So what happens to, so let's think of our seasons of the year. What happens to the dirt and to the ground through our different seasons? So let's think of wintertime and summertime. Thinking of the ground. What's the difference between the ground in the wintertime versus the summer? Aries?
Okay, so in the summer, the ground is like just normal dirt.
Normal dirt.
And in winter, there's either snow or before the snow guys, like the dirt will have like ice crystals form inside it. So you break the dirt and it'll be ice crystals.
Okay, I like that. Johnny?
so at wintertime, like the water that's already in the dirt and mixes with dirt freezes, and that's what makes the dirt super good.
Right. And during the summer, your dirt is going to be very dry. During the winter, it's going to be very wet, very moist, right? Kind of like what Johnny was saying, it can freeze. So what's going to happen to the dirt is it's going to expand. During the summer, it's going to contract because it's losing that liquid. So what's happening to houses, to buildings that are sitting on top of dirt, sitting on top of rock, right? What is happening? Well, why is there cracks that end up being in foundation of houses or any type of building? That's because over time, the dirt, the foundation underneath, which is the rock, the dirt, all that, it's expanding and it's contracting over and over again. So you have to make improvements to your house every year. Yes, Caleb?
So sometimes like you leave a rock over the dirt, after when it like freezes it all up, and then after it thaws, the rock will actually sink into the dirt. I've seen that sometimes. Like when it snows, or if it's not snowy, but it's really cold, I just see the rocks inside like a hole and they'll just fall in.
Yep. I just put in like a gravel path that goes from the front of my house to the back side of my house to go underneath my porch. And when doing that, one thing I've noticed already is that the gravel, it's lower already. It's starting to sink a little bit. And so now I have to add more gravel to the top because it's getting too low now because I'm starting to be able to see the tarp underneath because the gravel is starting to settle. The ground is settling more. So this coming spring, I'm gonna have to put more gravel into my gravel path that I just put in over summer. Max?
So that's why when you have like when you put in a paved road, we had to put like a bunch of gravel down so that it didn't sink all the way down. So if you put it on and then you do it, it's not gonna just instantly go down.
Exactly.
It's gonna stay up. It's actually like going down.
Exactly. Yeah.
Like a lot.
Yep. All right. Yes, get this one written down. More about mechanical and physical weathering. This might be the last one we get through today. So the last thing we're going to talk about with mechanical and physical weathering is ice wedging. Ice wedging. So ice wedging, what is happening? There's a frost and freeze thaw cycle that's happening. So when liquid water goes into the cracks and then it freezes, that causes cracks to get wider. So this picture does a great job of explaining what's happening. You can see some cracks in this piece of foundation. We can think of it just as a brick, right? What's a brick made of? It's made up of sediments, right? So this brick has some cracks in it. There's water inside. What happens during the winter time? That water is going to freeze. What happens when water freezes? It expands. It expands. So what's it gonna do to that crack? It's going to force the crack to get bigger, right? Why do they tell you? Some of you might not know this, but when you guys are homeowners or when you're renting a house one day, one thing that you're gonna hear, or maybe you've heard your parents say this, is if you have your hoses on, you need to make sure your hoses are off and you need to make sure all the water's out of the faucet, out of your hose,
For the pipes.
because your pipes are gonna freeze over, right?
Oh, actually,
So if you leave water in like your hose, what's gonna happen if there's a bunch of water filled up in that hose? What's gonna happen to the water? It's gonna freeze and it's going to expand. What's gonna happen to your hose? It's gonna crack, it's gonna break, it's gonna pop, right?
actually, if you
Yes,
leave
there is.
your hose on and it's not even winter, it'll still break your hose because
Yeah.
the water pressure builds up and pops in it.
Right.
But also for the gravel you put on, we had to get a log gravel. We had like 14 tons of gravel.
14 tons.
Well, we're covering like in 2 acres with the gravel.
That's spending.
We've already have it.
Yeah.
And we also, because we used to have cement there that was not cement asphalt, but made actual road.
Yep.
But they broke that apart because we didn't like it. Well,
So any questions here with the ice wedging section? Makes sense so far, right?
Yeah.
Yeah. Yes, Brady?
One sec. Physical and chemical change. I was just think the physical was in like something smashing it or impacting it. Like,
Yep.
like with a force, like with some sort of force in some way, and then chemical, I like to think of it as slowly deteriorating.
Yep. So water changing from solid, liquid to a gas, those 3 phase changes, would that be an example of physical or a chemical change? Physical or chemical change? What do you think? Water changing from solid, liquid to a gas. Is that an example of a physical or chemical change? Those of you who've taken physical science with me, Aries, Bethy, William, Ian, and Courtney for half theory, you 5 should know this.
wait, was that?
Oh,
Courtney, do you remember?
What was it?
So solid, water changing from solid, liquid to a gas, is that gonna be a physical or chemical change?
Chemical.
That was physical.
The
Nope,
composition,
because-
chemical composition
It
never
was-
changes.
Yep, because the composition of the water is still gonna be H2O. It's just gonna be water as a gas, water as a liquid, water as a solid, right? It's still gonna be H2O.
Physical this time.
Good job.
It's because I thought about all was particles heating up and stuff like that.
Yeah.
Yeah, I know, I remember.
Quiet, please. So here's one more example of what happens with frost wedging. So you can see water filling up the crack, it's freezing, and what can happen? It can break that rock apart. What's gonna happen when you see a bunch of ice like that? Well, same exact thing. You're gonna see the erosion of, right, the icicle could actually fall off. But if it gets in between that crack, it's gonna break that rock apart.
This is your
All right.
bottom left picture.
Oh, yeah,
Just the
Bruce.
one from the book zoomed down.
Okay, so that's where we're gonna finish off today. So go ahead and start getting cleaned up. Start getting cleaned up. This is where we are ending today.
You see that picture? Now look at this picture. That's just
Hang on.
the zoomed out book picture.